Okay, me again. Right, we're going to look at what happens if you change the temperature, if you increase the temperature or decrease the temperature in an equilibrium. Now the important thing is to look at the forward reaction, the reaction that goes towards the product is the forward reaction. The forward reaction in this case is exothermic, so it's got a negative view. Now we haven't done this topic yet, but you have done exothermic reactions in year 9. So an exothermic reaction, heat is released to the surroundings. So if heat is released, the temperature goes up. Yep. So an exothermic reaction, the temperature goes up. So if I'll put this down here. So an exothermic reaction, temperature goes up, and endothermic reaction, temperature goes down. So if I increase the temperature of this reaction, Le Chatelier says the equilibrium does not like it. So the equilibrium has to move to where there's a decrease in temperature because it's an exothermic reaction, so it's an increase in temperature. If I increase the temperature more, the equilibrium doesn't like it, so it's going to move to where there's less temperature or less heat. So the equilibrium moves in the opposite direction. So you end up getting more of the reactants, which you don't really want. So for this reaction, this is called the Haber process, which is very, very important. We'll learn about that on Wednesday. But in this reaction, it's an exothermic reaction. So if I increase the temperature, it moves to where there's less temperature. So it moves in the reverse reaction. Yep. So this reaction actually prefers a low temperature to push it towards the products. But we'll learn a little bit more about that on Wednesday. I just want to clarify, if you increase the temperature and it's an exothermic reaction, it will move in the opposite direction. So it will move towards the reactants. And if you increase the temperature and it's an endothermic reaction, then it will move towards the products. Okay?